Myself, Vasundhara Shukla, Assistant Professor in Electrical Electronics Department of Oriental College of Technology, Bhopal. In last lecture, we have discussed common emitter configuration of BJT. Today, we discuss common collector configuration of BJT. In common collector configuration, collector terminal is taken as common terminal for both input and output of transistor. The circuit diagram of NPN and PNP transistor of common collector configuration is shown in figure. As in common base and common emitter configuration, the emitter junction is forward bias and collector junction is reverse bias. The flow of electron is controlled in same manner. The input current is base current and output current is emitter current in common collector configuration. Now we discuss current amplification factor of common collector configuration. It is the ratio of change in emitter current to change in base current. It is denoted by gamma. The current gain in common collector configuration is same as in common emitter configuration. The voltage gain in common collector configuration is always less than 1. Now we discuss relation between gamma and alpha. Gamma equals to change in emitter current to change in base current, and alpha equals to change in collector current to change in emitter current. IE equals to IB plus IC. Here we find the value of IB. We get delta IB equals to delta IE minus delta IC. This value is put in gamma equation, where gamma equals to delta IE divided by delta IE minus delta IC. Numerator and denominator both divided by delta IE. We get 1 upon 1 minus alpha. Now we discuss expression for collector current. In common base configuration, we get total collector current value is IC equals to alpha E plus ICBO, and IE equals to IB plus IC. Here we find IC value, that is IE minus IB, and put this value in place of IC. Here we get IE equals to IB plus alpha E plus ICBO. IE value shifted in left side. So we get IE bracket of 1 minus alpha bracket close equals to IB plus ICBO. IE equals to IB upon 1 minus alpha plus ICBO divided by 1 minus alpha. 1 upon 1 minus alpha equals to beta plus 1. So again we write IE equals to beta plus 1 IB plus beta plus 1 ICBO. Now we discuss input characteristics of common collector configuration. The characteristics plots between base current and base collector voltage at constant collector emitter voltage. Now we discuss output characteristics of common collector configuration. In this, characteristics is plot between emitter current and base collector emitter voltage at constant base current. The output characteristics explain in three regions: saturation region, active region, and cutoff region. In common collector configuration, if the input current or base current is 0, then the output current or emitter current is also 0. As a result, no current flow through the transistor. So transistor will be in cutoff region. If the base current is slightly increased, then the output current or emitter current also increase. So transistor in active region. If base current is heavily increased, then the current flowing through the transistor also heavily increase. Transistor fall into saturation region. In next lecture, we discuss load line. Thank you.